Hey everyone, Cranshark here with Crashworks 3D. And in this video we're going to go over setting up your A.L.I.S.H.A board that you just got so you can motorize your faceplate. Stay tuned. Okay, so you've received your board in the mail and you're ready to take it out of this packaging and get started. Before you do, a couple of things to make sure you don't ruin your board in the process. One, make sure you got a nice clean dry surface. I like these silicone mats. You can get them off of Amazon. I'll provide a link to them below. The other is read the instructions. Take your time, read through them. If you got any questions, feel free to reach out to us. We're on Frankly Built's Discord. I'll have a link to that down below as well. We've got our own Crashworks 3D channel there for you to check out. You can also reach out to us in the comments here on this video, as well as through eBay, or maybe I'll even make an email address. Who knows? Okay. Okay, you got your clean working area. You've taken your board out of the bag. We're going to talk about the A.L.I.S.H.A Mark 11 and the A.L.I.S.H.A Mini version 6. And if you bought the Penelope board, we'll also talk about that for a little bit. So, if you got the A.L.I.S.H.A Mark 11 board, all the boards come with cables. The Mark 11 comes with 2 servo cables, 2 LED cables, and 1 power cable, and 1 switch cable. Just real quick mention on the power for these boards and what's different. The A.L.I.S.H.A Mark 11 board can be powered through this USB mini port, or it can be powered through this JST connection, which is what this power cable is for. You can choose either way. We'll talk about some of the differences here in a little bit. On the A.L.I.S.H.A Mini, make sure you only power it using the JST connector. Do not power it through this USB port here. That's just for programming. If you plug in a USB micro cable to that, you may risk damaging the board itself. We didn't design it to be powered off of that. So please, just a note of caution there. On the A.L.I.S.H.A Mini board, you're going to have roughly the same cables with one slight difference. So you'll have 2 servo cables, a switch cable, a power cable, and then you'll have an LED cable. Both LEDs are going to get spliced into this, and it's also it's a 3-pin connector. That's for future use if you want to use NeoPixels instead of just regular LEDs. For the Penelope board, you're just going to get 1 power cable, and we got the JST connectors on both ends, so you can easily just power this into either board like this. Boom, boom. And on the Mark 11, boom, there. Penelope board is if you got a smart battery. Smart batteries are designed to shut off if it doesn't think it's charging something. Our boards draw such a low amount of energy when you're not running the servos all the time that the batteries don't think they're charging anything at all, and it'll shut off. So that's why we created this. Makes it even easier to plug everything in down the road. So now that we've covered what comes in the board, oh, I almost forgot. Stickers. Oh, and did I mention instructions? Again, please take some time, read those instructions. Okay, so now you got everything laid out. You have an idea of what you're dealing with. Next thing we're going to go over is the different components that you're going to be plugging into this board. Okay, so we've gone over the cables that come with the board and everything in the package. Now we're just going to talk real quick about the different components that you're going to be plugging into the board to make it work. So, if you've done your research and your homework and you've read those instructions, you're probably going to have at least 2 servos. These are knockoffs. I'll mention that. We recommend the Tower Pros. was making this video, I realized all my Tower Pros are already installed into my helmets here. Again, if I can find some links to some genuine Tower Pros, I'll provide them, but at the time of making this video in late summer of 2023, we've been having trouble finding consistent places to go and get them. Basically, you'll know you got knockoffs because there'll be a light pink label. You see it doesn't say Tower Pro on them, and you probably got them for, you know, $1 or $2 each. The Tower Pros are going to run you, again, at this time of making the video, probably anywhere between $5 and $10 per servo. So it's a little more money, but definitely worth it. Get a little more consistency. Actually, I think I do have one Tower Pro. So that's what the label looks like on an actual Tower Pro. I don't know if you can see that okay in this light, but just for reference. Okay, so you got your servos. You've got your LED eyes. Okay. And again, these can be found in various places. I'll post a couple of links where you can find them. I get mine from AliExpress. As long as you're willing to wait a month, maybe 2, for them to arrive. Order well in advance. Let's see, what else do we have here? We got a switch. I've already wired up a limit switch to my cable. This is what a limit switch looks like. It should be a normally open limit switch, probably similar to what you see on your 3D printer that kind of tells the printer when it's reached the edge of its axes. You're going to want some kind of battery. This is a nice little 5-volt 2-amp battery that I got. It also has a nice solar charger on it, so if I'm at a con or something, I can have a couple of these over in my car charging, so that if one dies, I can just go swap them out. You're going to need some kind of cable connection to your battery. This one I think I got off of one of my printers that I'm not using. Again, we'll cover splicing different wires in another video down the road. This is what we're starting with. I'm going to assume you already 3D printed your servo enclosure as well as your servo arms. Those will come in handy. And then I also recommend you print out one of our enclosures. These can be found out on Thingiverse. Again, I'll provide a link. We designed various enclosures to help protect your board while you're either making or when you install. I put a little lip in there to catch the board and hold it in place. I don't know if you can see it. This isn't the best color of filament for videoing, but whatever. But it's nice because you can glue this into your suit or helmet, and then you can remove the board if needed to, you know, add things, change up the code, whatever. So these are all the things that you're going to be working with your board. In this next segment, we'll cover plugging everything in. Okay, so you got your components ready, you got your boards ready, you got your wires ready. So now we're going to plug everything in. First, we're going to do a shameless plug for our stuff. Okay, with the Mark 11 and the AM6. So you're going to take your 2 servo cables, you're going to plug those guys in. Servo 1, servo 2, it's going to be important to keep track of which servo is which. So I've got the A.L.I.S.H. Mark 39 helmet here that I'm working on. So thanks, A.L.I.S.H. Servo 1 is here on the left side. So this cable here. So you're going to want to make sure you plug that in to this cable here. And you're going to want to make sure the colors line up. All the colored wires on each one. And we're going to plug in servo 2. Okay, now we'll plug in the LED eyes. I've already crimped these LED eyes. I didn't use the cable provided. We test these boards all day long. Every time we make a board and get ready to ship it, we test it. So we plug everything in, run it through some tests and diagnostics each time. I recommend taking some time to learn how to crimp cables yourself. These are the same JST connectors that you're going to find on the majority of 3D printers. So if you ever have a cable break or need to recable one of your 3D printers, this is a handy skill to have. So I recommend learning how to crimp your own cables. So LED eyes plug in down here. Our instructions, we label in our instructions every one of these ports so that it's easy for you to figure out what plugs into what. We're going to plug in our switch next, and I've already pre-soldered a limit switch to the cable. We'll cover soldering and different ways you can crimp and connect wires in another video. So we're going to plug that in. And since I'm using a smart battery, one of your cell phone charging batteries, it's 5 volts, 2 amps is the recommended power for it. Definitely has to be at least 5 volts, 2 amps. You don't want to go over 7 volts because you're going to burn out the servos. And you don't want to go under 2 amps because the servos draw that much energy to properly operate. Now you'll notice I did not put the servo arms on the servo mount yet. And that's because when the board first powers on, the servos are going to move to their home position, so to speak. And that home position is the faceplate closed position. And so you can see right now the way it's oriented is this will be the front of the helmet. This will be the back side of the helmet. So left side, right side. And the servo arms will start in this position here. And then when everything's working and you go to open the faceplate, they'll swivel up. And I'll show that here in a moment when we plug in the power. So we got our USB cable, and the other important thing to note is you never want to plug or unplug anything into the board without removing the power first. So always power down your board before plugging anything in or out. Okay, so we've got everything plugged in. We got our servos, our LED eyes, our switch, and our power. Next thing we're going to do is we're going to power this thing up. Okay, so we've got everything plugged in. We want to just double check our connections, make sure everything's a good solid connection before we plug in the power. If you are just setting this up for the first time and you're excited and you just want to twist your wires together to see everything working, just be aware that that may cause a short. You may not have good connectivity, and so the board may not fire up the first time as expected. So just a couple of things to look out for. Same thing even with your switch wire, leaving those bare and just tapping them may not always get the same results as actually having a switch attached. So make sure your battery's fully charged. I actually didn't have that battery fully charged that I showed earlier, so I'm going to use this one instead. Again, it's a 5 volt, 2 amp smart battery. So you plug it in, and you'll wait for the board to initialize. The servos will home. Then the lights will blink on. It's a blink on effect that we programmed in. That's normal. So now your servos are in the home position. What we'll do is we'll attach the servo arms and hit the switch and make sure that the servos move the way we expect them to. So here we go. So, okay, we're gonna put these guys in the front like this and like this. Okay, and you'll see there's the angles are slightly off. That's not gonna matter once you put the helmet on. They're gonna kind of get in position on their own. don't try and rotate the arms to get them there, because when the servo moves, it's just going to realign itself to where it thinks it needs to be anyway. So we've got those set up, and this is the faceplate closed position. We're going to tap the switch and it should go to the faceplate open position. So there, you saw that flip open. That's the open position, and it swings back that far. Don't panic thinking that that's going to swing too far back for your helmet, because the orientation in your helmet, I don't know if I can show it at this angle, but it's not going to be 90 degrees in the helmet. It's actually going to be tilted forward. And so this is going to put it over the back of the helmet, or the top of the helmet. And in a future video, I'll show you what that's really going to look like when it's actually installed in a helmet. So, okay, so we were successful at opening it. Let's go ahead and close it again. And the light should fade on, again by design. We've got some configurations in there if you want to change up how your eyes light up and turn off, and brightness and all that. Again, we'll cover that in another video later on. So, you know, just a couple extra features. If you double tap, that should turn the LED lights off while the faceplate is down. Double tap again, turns them back on. If you press and hold, they should fade down. And then I like to call it, they go around the horn and start to brighten up again. So if you want to adjust them to a lower setting at a con or something because you can't see, just press and hold the switch while you're operating. And then when you open them up again, they're going to turn off. You're going to close them, and they're going to go back to full brightness again. So that's the Mark 11 all wired up and working. We're going to do the same thing now on the Okay, so same thing with the AM3 board now. We're going to get this all plugged in and ready to go. So again, servo 1 goes here. Servo 1 cable. Let's make sure we got the right one. Trace that out. Okay. Plug that guy in. Okay, servo 2 cable. Plug that one in. Okay, those guys are all plugged in. Make a little room here for everything, flatten everything out so I can see what I'm doing. Okay, switch cable. LED eyes. Again, I already spliced my LEDs and crimped my own 3-pin connector. Again, if you do this, pay attention to where the positive and negative go. These are LED diodes, which means the current's only going to flow in one direction. So your LED eyes are not going to light up if you don't wire those up properly. Okay, so those are all in there. Plug in the power cable to Penelope. Okay, USB cable, and we are all ready to power this guy up. So next thing we'll do is plug in the battery. Okay, so we got everything plugged in, checked our connections, we got good connectivity everywhere. We got the servo ready to go, Penelope ready to go. Gonna grab our battery here and plug this in. Okay, same thing. Servo arms are disconnected so that the servos can home in. I don't know where it was left off. Servos home in, LED eyes light up. We're gonna attach our servo arms here. Okay. Try and get those a little closer. I don't know. Maybe line this guy up down here. Yeah, so what's going on is the teeth, the way they're aligned in these guys, It's off by like 1 degree. So anyway, okay, here we go. Closed position, open position. LED eyes go off, close, boom. And again, you notice that we have the servos move a little bit slower when they close so that the faceplate doesn't slam down. Double tap, turns them off, double tap, turns them back on again, maybe. There we go. So double tap, actually I forgot on the AM3 or AM6 and the AM3, double tap actually sets different levels. It's not just off and on, but it'll set different brightness levels. Again, the programming's slightly different because these boards are smaller. They don't take as much code as the bigger Arduino Nano. So open, close, and there you go. Next, we'll talk a little bit about troubleshooting if it doesn't work as planned. Okay. Okay, so let's say you got everything plugged in, got your board all set up, and things aren't working as expected. So we'll go over a few different things to troubleshoot and help you figure things out here. So the first thing we'll talk about is troubleshooting power. So one thing to look for is there should be a red or some colored LED that turns on either one of the boards, letting you know that you got power to it. So that's the first thing to check for. So if you don't have a light to that, check your connections, check your power source, check all these cables, your USB cable connection there. Also, check your batteries. Make sure they're fully charged. This battery that I talked about in the beginning, it wasn't fully charged when I started recording the video, and so things didn't work as expected. So I grabbed another battery. I grabbed this one, it was fully charged, and everything worked as expected. Check to make sure that that battery is 5 volts, 2 amps minimum. This little battery right here is 5 volts, but not 2 amps. I think it's only like 1 amp. It's hard to read information right there, but this will not power all the servos and LEDs properly. And so if you try and plug this in, you're going to get weird results. If you have the servos start up, they only twitch, but you do have lights on your board, and say the LED eyes light up, could be not enough power. And especially with the AM6s and the AM3s, if they're underpowered, they will definitely behave badly. Sometimes even the code gets messed up on there and you have to reflash it. And I'll cover how to reflash one of these boards in a later video. And that's just re-uploading the code. So if you're not sure about your battery, try a different battery. Try a wall wart, one of these wall charging adapters. Plug this into your wall, plug it into here. Again, just make sure that it's 5 volts, 2 amps. Some of these wall chargers are only like 5 volts, 1 amp. Same thing if you try and plug your USB cable into like your PC or computer. They don't always output an even 5 volts, 2 amps. Could be less. So those are just a few things to look for with regards to power. Next up, we'll talk about troubleshooting your servos and the connections there. Okay, so let's say your power is all working, good power, but your servos are still doing something funky. First thing we'll cover is talking about what happens to these guys when you have them plugged in backwards. So we're going to swap out these cables. I'm going to show you what happens real quick here. Oh, did we actually swap them out? There we go. Okay, again, power's off when I'm unplugging or plugging stuff in. Plug that battery in, give it a minute to initialize, And so this is a common problem where the cables are swapped and faceplate is in the open position, but the LED eyes are on. That's actually opposite of what you want. So when they're closed, LED eyes are off, faceplate is closed. That's not what you want. You want it actually the other way around. And so no problem. All you got to do is just get those cables swapped. Again, you know, label which one's servo 1 and servo 2 because you're going to be staging your modules like this, board and your servos and everything else. Just to make sure everything's working. Then you're going to install in a raw helmet and make sure the faceplate lines up and everything's working before you paint it so you don't mess up your paint job. And then you're going to take it back out again and you're going to install it again after you're done painting. So there's multiple times where you're going to be uninstalling and reinstalling these boards. So label things, keep track of how things are, and that'll save you a lot of trouble down the road when you're working with these boards. So yeah, so that's one scenario. Another scenario is maybe the servos are just twitching. Again, double check your power. Double check the quality of the servo. Again, these knockoffs, you're always taking a gamble. I'm actually quite astonished that these knockoffs are still working for me. I didn't expect them to keep going like this. So sometimes you get lucky. But yeah, these are some of the first servos that I bought and learned that the Tower Pros are the way to go. The other thing is maybe the servo just starts spinning and spinning and spinning. Chances are is you bought a 360-degree servo versus a 180-degree servo. So when you're buying your servos, double check that it is a 180-degree servo. What happens is the code knows how to send the right signal to a 180-degree servo versus a 360-degree servo. Different signals need to be sent to. There's a little processor on the servers themselves that interpret that signal. So that's why it's difficult trying to get a 360-degree servo to work with our code. So those are some things to look for in servos and troubleshooting them. Again, make sure your servo cables are actually plugged in properly. You can see we've got yellow to yellow or orange to orange, brown to brown, red to red. If they were inverted, the servos wouldn't work. They could also send a bad feedback signal back to the board, causing it to either lock up the code or damage the board. So, please be careful and double check those connections. If the servos don't move at all, another thing to check for example, on the Mark 11 board and also on the Mark 10D and the Mark 10J boards, we've got this power jumper here. And so if you pulled that out at some point, maybe you're just like, I don't understand why that's there, I'm just going to pull it out. What that does is it jumpers power over to these ports over here, the red and purple ports, so that you can supply additional power or a separate power source to your board. So let's say you're running servos and NeoPixels and you need more than just 5 volts, 2 amps. Maybe you need 3 amps or something because you're running a lot of lights. And so, yeah, we'll go into more detail about how to supply additional power to your board later. But one of the things that might be going on is this cable got disconnected for some reason. So check for that. Okay. So some other issues that you might run into on the AM6 board is the LED lights will kind of just start blinking. If you pay close attention to those blinking lights, it's actually an SOS signal. And what it's signaling is, first and foremost, is you probably got your switch wired wrong over here on this board. So make sure you got that switch wired properly. and everything's working there. Sometimes when you tap the wires together, if you don't have an actual switch connected, you might get the timing wrong. You may tap them for too long. You may tap them for too short. That's why I like actually attaching a switch to the cable itself when I'm getting everything set up. And then I'll move it later if I need more cable, if I'm running it down my arm or whatever for a full suit. So those are things to check for. Make sure you got everything plugged into the right ports. Switch is plugged into the switch port. Power's plugged into the power port. Servos are plugged into the servo port. LEDs are plugged into the LEDs port. So next we'll talk a little bit more about troubleshooting the LEDs themselves. Now we'll talk a little bit about troubleshooting the LEDs. So let's say on the Mark 11 board, your only one of the two LEDs turn on. So a simple thing to do is disconnect the power again and swap them. Make sure that, you know, if that same LED that's not working on one port doesn't work on the other port, then chances are you got a bad wire or something going on with that LED, and you can troubleshoot it down to that one LED wire. So give it a second here to power up. So if you do, you know, again, check those JST connections there. And again, you can see there's heat shrink here. You may be able to just cut that back a little bit and see if a wire didn't come loose there. I know when I'm bending these things around and installing them in a helmet, every once in a while I'll bend one of these a little too much and I'll break a wire in here. Not a big deal if you got soldering skills. Solder it back together and you're back in business. I've yet to burn out one of these when I'm using the proper power. We also put an extra resistor in these boards to limit how much power goes to these LEDs so they don't burn out on you. But it is entirely possible to overpower one of these LEDs and burn them out. So it's always, it's not impossible, let's just say that. There's always that chance. So those are things to check out for. On the AM6 board, you'll have two LEDs wired together. So, you know, just check that you spliced them together properly. You can see the work that I did here. I basically twisted the pairs together and then attached a single wire and then crimped that together. Make sure you got the connections right, positive and negative. These are diode LEDs, which means that current will only flow in one direction. And so if you had these wires backwards, then it's not going to light up. So you may need to switch them. On our boards, you should be able to see tiny etchings on the board for plus and minus, right? Plus is red, minus is black. Things to check for with the LEDs. On the Mark 11 board, if you power on the board for the first time and the LEDs are doing something like this, where they're just, you know, cycling on and off, dimming and brightening again, chances are you've wired your switch wrong and it's just going in a loop and it can't really do anything else. So that's something to check for. Again, on the AM6, like I mentioned before, you'll see like an SOS signal or some just strange blinking cycle that the board's doing. Chances are you've got your switch wired wrong. The easiest thing to do is just unplug the switch from the board, power it up, and see if it's doing that still. So stuff like that. So those are the main areas that you can troubleshoot at a high level: is power, your servos, your switch, and your LEDs. Those are the four things that come together to make this board work. So I hope some of these troubleshooting tips are helpful. Worst case scenario is like you need to reload the code. You know, every once in a while, low power is a pretty common issue or if you don't have enough power to the AM6, the code will get hung up and you'll have to reload the code. So those are things to look out for. Okay, so I hope that you all found this video helpful and informative, and it's set you up for success in getting your boards working. In future videos, we'll talk about more tips, techniques, different things you can do with the boards that you never thought were possible, and other applications for the board. Thanks again. This is Cranshark with Crashworks 3D. I thank you, and the Crashwork team thanks you. Please like and follow and comment on this video, and we'll see you soon.